Now we're going to take up one more problem on projections of laminas. How to analyze this problem number 105 and solve by using the sketchbook. The problem reads as: a hexagonal lamina of sides 25 mm rests on one of its corners on HP. The lamina makes 45 degrees to HP and the diagonal passing through the corner on which it rests is inclined at 30 degrees to VP. Draw its projections. So first he says it is resting on one of its corners on HP. So obviously the initial position has to be on HP such that it is resting on corner. So the extreme end point should have single points. So that is possible only when the sides are parallel to VP. So that is the condition. So when you keep this the sides which are parallel to VP, then we can get the extreme points will going to be the corner position. So here A is one corner and D is the another corner. So as we see here, the surface of the lamina is parallel to HP. Since the surface of the lamina is parallel to HP, so we are getting the true shape in HP. So that is A, B, BC, CD, DE, EF and FA. All the sides will going to have equal length of 25 mm. And then as the surface is perpendicular to VP, so you are getting a line in the vertical plane. When you look from the top view, all the 6 points are visible. So A, B, C, D, E, F. So when you look from the front view, the points which are near to the observer is visible. That is A, B, C, D, which are nearest to the observer. Therefore, in the front view, A dash, B dash, C dash, D dash is visible. And when you look from the front view, both E and F is away from the observer. Therefore, E dash and F dash will be invisible. So this you can see the same thing here. In the top view, you're going to have a hexagon which is of a true shape of 25 mm and wherein the surface is parallel to HP. So you're getting the true shape in the horizontal plane. And when you look from the front view and the surface is perpendicular to VP, so that is the reason why you are getting a line in the front view. Here this point is a corner point and here this is also a corner point. Now we go to the next condition wherein the lamina makes 45 degrees to HP. So when the surface when it is resting on one of its corners, so since there are two corners here, both A dash and C D dash, so either you can resist on A dash or you can resist on D dash. If you are restricted on D dash, then you have to rotate in clockwise. If you are resting on A dash, then you have to rotate in anti-clockwise direction. So here we are resting on A and the surface is inclined at 45 degrees to HP. So once the surface becomes inclined at 45 degrees to HP, then still this surface is perpendicular to VP. So that is the reason why you are getting a line in the front view, and wherein when you look from the front view, A, B, C, D is near to the observer. So A dash, B dash, C dash, D dash is visible. E and F is away from the observer. Therefore, E dash and F dash becomes invisible. And when you look from the top view, so this is the condition wherein you will be able to get the hexagon. And here A dash, B dash, B dash, C dash, G dash, D dash, D dash, E dash, E dash, F dash, and F dash, A dash, all the sides are inclined to HP. Therefore, all these sides becomes in apparent length. And as the diagonal A dash, D dash is inclined to HP, so you are getting AD is the diagonal which is in apparent length. Then, and the diagonal passing through the corner on which it rests is inclined at 30 degrees to VP. So which is the diagonal which is passing through the corner? The diagonal which is passing through the corner on which it rests. The A dash is the corner which is resting on HP. The diagonal passing through the corner becomes AD, so which is inclined to VP at 30 degrees. So as it says it is inclined to VP at 30 degrees, again he has given the true inclination, but here in the top view as the diagonal is inclined to HP, so you are getting the apparent length, but the inclination is given is the true inclination. Therefore, according to the projections of lines, on the true inclination line you have to get the true length, and on the apparent inclination you have to get the apparent length. As we need to reproduce the second position top view in the third position, since the diagonal given is the true inclination, therefore you cannot transfer directly on the true inclination line. Since in the second position top view you have the apparent length, so we need to find out the apparent inclination. So what is the procedure to find out the apparent inclination? So to do that, consider any convenient point at some point from the xy line, and you mark this point as A. Then you draw a horizontal line, and then through A with respect to the horizontal, you measure an angle of 30 degrees to VP, and then you draw a line. And once you draw this line, so this will going to be the true inclination line. Since it is the true inclination line, the diagonal, the true length of the diagonal you have to be considered. Where you are going to get the true length of the diagonal? In the first position top view, you can see the diagonal AD is parallel to HP, so you are getting the true length here. So you measure the distance from A to D, which is 50, with A as center, cut an arc on the true inclination line. So therefore, you are going to get that 50 here. Then you draw the locus, and then you take the apparent length of the diagonal, which is 35.3553, which is AD. You take that distance, and with A as center, cut it on that locus. Then you will going to get the beta inclination line. So on that beta inclination line, you reproduce the second position top view, and then you project to get the front view. So this is how you will be able to find out the beta inclination line. So how we will going to be analyzed in this is, here once it is inclined at 30 degrees to VP, so here as we know this is the apparent length, as we rotate the second position top view such that the diagonal AD is the one which will going to be rotated till it becomes 35.3553. So once you get that, and then to this, when you write the corresponding front view, you will be able to get this drawing. So this drawing and this drawing is one and the same. So this is how you will be able to analyze this problem in 3 dimensions. Now we will going to try to solve this problem by using the sketchbook. So to do that, first we will going to draw a thin XY line. Draw a horizontal line in the sketchbook with a thin line. You mark XY and VP and HP. So first we need to start from the top view, as we know how to construct the hexagon. Consider any point, and from there by using the compass you measure a radius of 25 mm and draw a circle, a thin circle. Then draw the extreme diameter, which is the horizontal one, because as you see it is resting on one of its corners. So you make sure the sides should be parallel to the XY line. So that is the reason why you have to draw this AD, the diameter. Then once you do that, with A as center, taking the radius of 25, cut on the circumference of the circle in the top side and also on the bottom side. Similarly, with the same radius, with D as center, cut it on the circumference of the circle on the top side and also on the bottom side. Then you mark the points as A, B, C, D, E, F. Join A to B, B to C, C to D, D to E, E to F, and F to A with the dark lines. Once you do that, then draw the vertical thin projectors line from each of these points. From A to XY line, from B and F to the XY line, from C and E to the XY line, and D to the XY line. And then as you see from the front view, A, B, C, D is near to the observer. So A dash, B dash, C dash, D dash are visible, and E and F is away from the observer. Therefore, E dash and F dash is in bracket. Join A to B, A dash to B dash to C dash to D dash with a dot line. Now, once we do that, so you need to reproduce the first position front view in the second position. So to do that, take any convenient distance from the first position front view and you mark that point here. Then you mark this point as A dash. By using the protractor with respect to the XY line, you measure an angle of 45 degrees and then draw an inclined line. Then by using the compass, take the distance from the first position front view from A dash to D dash with A dash as center. Cut an arc on that 45 degree line and you mark this point as D dash. Similarly, you measure the distance from A dash to C dash, which will going to be the same as from D dash to B dash. With A dash as center, transfer it on that 45 degree line So to mark this point as C dash and E dash with the same radius, from D dash as center, cut an arc on that 45-degree line to mark this point as B dash and F dash. Then join A dash to D dash with a dark line. Then draw a vertical projector from A dash and D dash to the top view and draw a horizontal projector from A and D. Both these two lines will going to intersect at this point, which is small a, and you mark that as small a and this as small d. Similarly, draw a vertical projector from B dash and F dash and draw a horizontal projector from B and F. Both these two lines will going to intersect at this point and also at this point. And you mark this point as B here and you mark this point as F. Similarly, draw a vertical projector from C dash and A dash to the top view and draw a horizontal projector from the first position top view. Both these two lines will going to intersect at these 2 points. You mark this point as C and E. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dark line. Once you do that, now we need to go for to find out the apparent inclination. So to find out the apparent inclination, why? Because we need to reproduce the second position top view in the third position, but in the third position, the diagonal passing through the corner on which the laminar is makes an angle of 30 degrees with respect to VP. So since he has given the true inclination, so first we need to take the true inclination. So to do that, consider any convenient distance from the second position top view and you mark that point as small a. Then draw a horizontal line from passing through the point A by using the protractor with A as center with respect to the horizontal. You measure an angle of 30 degrees and draw an inclined line. So this is the true inclination line. On the true inclination line, we have to get the true length. So the true length of the diagonal, which is AD, will be from A to D here. By using the compass, you measure the distance from A to D, with distance will be equal to 50. With A as center, cut an arc on that 30-degree line. So once you get that, you will be able to, from this point, you draw a horizontal thin line. So you are drawing the locus now. Now you take the second position top view distance of the diagonal ED with A as center. By using the compass, you measure the distance from A to D with the same A as center. Cut an arc on the locus line. So once you get this, so you're going to get this point and you mark this point as D. Then join A to D with a thin line. Then you measure the distance from A to this point, which will going to be the same as from D to this point. Then transfer from A on that beta inclination line till here, and also from D with the same radius, you cut it on that beta inclination line. Once you do that, then with respect to AD, you draw a perpendicular from these 2 points as shown. So that is, you have drawn from this perpendicular to this inclined line AD. Similarly, from this point, you draw a perpendicular with respect to small AD now. Once you do that, then by using the compass, you measure the distance from this point to B and also from this point to F. And similarly, from this point to C and also from this point to E. All these 4 lines will going to have the same distances, and transfer from this point on to F, that is to the top side, and also from this point towards the bottom side. Similarly, from this point, transfer it on to the top side, and also from this point, transfer to the bottom side. Then you mark this point as B, C, then E and F. Once you get this, then you join A to B, B to C, C to D, D to E, E to F and F to A with a dark line. Then you draw a vertical projector from point A to the front view, that is to the XY line, and you mark this point as A dash, and then draw a horizontal projector from D dash and draw a vertical projector from D. Both these 2 points will going to intersect at this point. You mark this point as D dash. Similarly, draw a horizontal projector from B dash and F dash and draw a vertical projector from B and also from F. Both these 2 lines will going to intersect at this point. You mark this point as B dash, and similarly at this point you are going to get it as F dash. Similarly, you draw a horizontal projector from C dash and A dash and draw a vertical projector from C and also from E. Both these two lines will going to intersect at this point, which is C dash, and you mark that point as C dash. And similarly, from E will intersect at this point, which will going to be E dash. Then mark these points. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash, F dash to A dash with a dark line. Then show the dimensions of this as the apparent inclination beta, and then don't show these dimensions, it is not required. And here you show the inclination, which is 30 degrees, and here the size of the hexagon is 25. How do I know that my problem is right? So here still in the final position, you can see one of the corner is resting on HP. The diagonal passing through the corner on which the laminar rests makes an angle of 30 degrees with VP, and the surface makes an angle of 45 degrees to HP, and this is a side of 25 mm. So this is how we will be able to analyze and solve the problem by using the sketchbook. Thank you.